We're back. All right, so let's look at number 9. We have to draw our own picture. Uh-oh. Oh, gosh. Okay. Well, first it says... Okay, F parentheses 1 equals 2. What did we talk about with that F business? F business comes from closed dots. Closed dots, okay? So this F business is a closed dot. Yeah. Okay, and the way this F business reads is F parentheses X equals Y. So this is a closed dot at 1, 2. All right. So if I were to draw a graph at 1, so to the right 1, up 2, because 1, 2 is XY, so to the right 1, up 2, we would have a closed dot. So automatically, D looks kind of okay because it's to the right 1, up 2. C to the right 1, up 2. Nope, we're missing that dot. B to the right 1, up 2. We're missing that dot. A to the right 1, up 2. We're missing that dot. Oh, look at that. So you could have found the right answer just from that dot. Okay, and then this other sucker says the limit as x approaches 1 is -2. Remember, limit means the y value. So the y value is -2. Okay, so that means when x is 1, so here's when x is 1, there's another y value of -2. But it's not closed because the only thing that is closed comes from the F business. Yeah. Okay, so this x value of 1 and y value of -2 is not closed because it's not that F junk. It's open. And when I say that F junk, I mean this stuff over here. Yeah, okay. So it's open. Okay. Now, check out that thing underneath. X approaches 1. That does not have a plus or minus in the top. So since it's missing a plus or minus, that means that from the left and the right had the same y value, so that's why I could use it with no little plus or minus in the top of the air. So because there's no little plus or minus in the top of the air, that means the left and the right curve meet at the same spot. So I'm not going to have a curve that jumps like C. See how there's like a break? Yeah. I'm not going to have a curve that jumps like A. See how there was a break? I'm going to have a curve that touches that open hole from both sides. And that looks like D. Okay. If you didn't get that last part, at least try and get this part. It can narrow down your answer choices. The F business has to be a closed dot. All right. It says, is the function continuous at 1? That means, do you have to pick up your pencil? So let's trace. Okay. When x is 1, right here, the question is, do I have to pick up my pen right there? Well, if I'm tracing this curve, I'm coming down, I'm at this bottom left, and I'm coming up, I have to pick, you see that? I had to pick up my pen to draw that open hole. And then, I gotta pick up my pen to draw this dot. So, no, this is not continuous. It's discontinuous. And it's discontinuous because these two dots are not at the same spot. Or if we look at part A, it says limit f parentheses x does not exist. Well, that's wrong because we got told it was equal to -2. See, up here it says limit equals -2. So A's or B's wrong because it says it doesn't exist, but they told us it was -2. Okay, f parentheses 1 says does not exist, but that's not right because they told us it was equal to 2. See, f parentheses 1 equals 2. Okay, so the only option is this D. And these funky symbols at the back end mean 2 holes at different spots. And that caused us to pick up our pencil. So those 2 holes at different spots make us pick up the pencil. And when I say different spots, I don't mean a hole here and a hole here. I mean the holes have to be lined up and down. You don't just pick a hole and a grab. We're talking about the 2 dots that you drew. That's at x equals 1. Did you have to pick up your pencil for that? And yes, we did. So it's discontinuous. And it's not B and C because they told us what these were equal to, actual numbers. Okay, let's go to 10. It says determine where the function 4x minus 2 is continuous. Okay, well, if you want to, you can press y equals and then put it in the calculator and press graph. And then if I have to pick up my pencil to trace it, is boo-boo. If I don't pick up my pencil, it's bueno. Okay, so let's go to y equals, clear, press 4x minus 2, go to your graph, and oh look, when I trace my pencil, I never ever have to pick up my pen. So this is continuous everywhere. So that means it's good everywhere. Nowhere do I have to pick up my pencil. Nowhere is there something janky. So since it's good everywhere, we're going to say negative to positive infinity. Okay, if you were wondering what's the math to back that up, on your test, if there is no x in the denominator of a fraction, then it's continuous everywhere at negative to positive infinity. So for this problem, I don't have a fraction. The x is not in the denominator because there's not even a fraction. It just says 4x minus 2. So it's continuous everywhere. All right, let's look at number 11. This is a piecewise. Okay, it says we need to graph it, and then it says some hoopla about discontinuity. Okay. Well, first, let's draw this beast. Okay. First, it keeps talking about the x being a 0, so that's important. Okay, x is 0 right here. Okay, and it says for x less than 0, and I know that's a less because, oh, look, you can already see I traced it on my hand already once today. When you make that alligator with your hand and then open it, it looks like a L. So this is to the left of 0 or less than 0. This other sucker, it does not make that L with your hand, so it's greater, or things that are greater are to the right of 0. Okay, so to the left of x, I'm supposed to have 1 plus x. To the right, I'm supposed to have 5 minus x. Okay, so if you want to, we can use our calculator. Okay, I'm going to put in, go to y equals and type 1 plus x and graph it. But the only portion I want to graph is to the left of 0. Well, if 0 is in the middle, all I want is this portion. I don't want any of this because I only want this line for left of 0. So my line is going to come, let's see if I can, looks like, okay, good. Looks like that kind of, and it's about to touch here. Okay, now, if you look at these pictures, there's dots. Okay, to figure out what kind of dot it is, you look at the alligator. Okay, this alligator has an equal, so it's closed. And it's because it has that equal sign. This other alligator, it's open because it has no equal. Okay, so we just graphed this first equation, 1 plus x, only on the left side. And the dot at when x is 0 is going to be open because that alligator did not have the equal to underneath it. It just had less than. Okay, now let's graph this right hand piece. So I'm going to go to y equals, type 5 minus x, go to your graph, and I only want the portion to the right of 0. So 0's right up in the middle, and I only want to look at from here to there, because this is the right side. Okay, so my graph is going to go something like that. Okay, that's that right line that I just drew. Okay, now it's going to have a closed hole because of that equal to on the alligator. Hot dog, we did it. Okay, A looks kind of right, good. B, the holes are wrong. So you have to know about those alligators. C, wrong, the holes are wrong. D, the holes are wrong. Oh, okay. So, A. All right, let's go to this next portion. It says locate all points of discontinuity. That means the open hole. Okay, so where is the open hole at? Well, it says x equals. What is x equals right here at this discontinuity with t? X is 0, so I'm going to put a 0 right there. Okay. Next piece says at the points of discontinuity, the values of the function f of x, there's that f of x business. Remember, f of x business, or f parentheses, means closed dot. So we want to look for the closed dot. Yeah. Okay. Sorry. So, okay, when x is 0, this closed dot, it's asking what's the y value there. Because it says we already found the discontinuity at x equals 0. Then it says discuss what happens at that discontinuity. Find f parentheses x. Well, that's only the closed dots. So this closed dot, we got to figure out where it happens. Oh gosh. It looks like I think 5. Yeah. So this happens at 5 on the y. All right. The last portion says find the limit as x approaches c of f of x, where c are the points at which f of x is discontinuous. Select the correct choice if necessary. Da 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 da. Okay, so this is saying find the limit where the graph was janky, because it says find the limit. So limit means y equals, okay, where c are the points at which f of x is discontinuous. That means where that jump is, or where that hole is. And we know it's where the hole is because it says at which f of x is discontinuous, and we already found that. In part A, we said the points of discontinuity are x equals 0. So part D is asking just kind of in general, what's the y value at x equals 0? Because that's when the graph is discontinuous. Well, let's see here. Remember, since this little c right there does not have the plus or minus, you have to consider the left and right, or both. And remember, the only way we have an answer here is if the last two answers were the same, or if the left and the right were the same. For example, if we look back at this picture, the limit as x approaches -2 with nothing written in the air is a number, because the last two numbers were that exact same thing. Whereas if from the right and left are two different y values, in general, we say the limit does not exist because those are two different y values. Okay. So if we're looking at the left of this, the left side of this curve has a y value of, I don't know, 1 maybe? Yeah, okay. Then the right side of the curve, we already saw what that has a y value of. It has a y value of 5. Yeah. So, in general, here at x equals 0, the limit does not exist because these two dots don't have the same y value. So this is going to be does not exist because the dots at x equals 0 have different y's. And you don't have to write these words on your test. I'm just doing it for the sake of your learning. Okay. Number 12. It says for x to the 4th, the instantaneous rate of change is known to be 32 at x equals 2. Okay. Instantaneous rate of change. Yeah. That's called the slope. So the slope is also, so the instantaneous rate of change is the letter m, or our slope. And they just told us it was 32. Okay. Then we're told that x equals 2. Okay, that's another important piece of information. Then they also told us at the very beginning f of x equals x to the 4. So they gave us 3 pieces of information. It says find the equation of the tangent line. Well, the equation of a tangent line is y minus y1 equals m parentheses x minus x1. That's the equation of a tangent line. And we know the m, it's that 32 from the instantaneous rate of change. Okay, we know the x value, and when I go to put this 2 in my formula, it's the x1. So that x1 is 2, and I had to write minus 2 because the formula says minus, okay? Then I'm going to get the y value from this f parentheses x to the 4th. So if I want to find the y value for an x of 2, I'm going to plug in 2 into this x to the 4th. So 2 to the 4th, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16. Hey, 2 to the 4th is 16, and this is my y value. y1 equals 16. Okay, so let's go over that. The instantaneous rate of change they give you, it's the m. The x1 they give you, it's the x. The y1 they don't quite give you, you have to figure it out. You use that janky equation at the very beginning, and you replace the x with whatever number they told you x was. Okay, so now let's replace the y1 with 16. So we're going to have y minus 16 equals 32 parentheses x minus 2. And you can type it in just like that. You don't have to finish it. It might count it wrong at the beginning, but then I'm going to go back and hand grade it and give you it correct. So you do not have to make this y equals. I'm desperate. Okay. All right. Let's look at number 13. I'm going to omit 13. I think this squared is going to make it too much. Okay. Sorry. If you already did it, I apologize. Okay, on your review, if you don't do this problem, I'll just bump it up to a 100 for you. Okay, so let's not do this on the test. It's too much. It's going to take too long, and we're probably going to get wrong because it takes too long. Okay, last question, number 14. Okay, 14 says, sketch the graph of f and determine whether f is non-different. Okay, well, we practiced this before. Okay. First off, we got to figure out what x we're looking at. The 1. Okay, so find when x is 1. Here it is. Okay. Second, let's go back and look at these alligators. This first alligator is not equal, so it's open. Second alligator has a equal, so use closed. Okay, let's try and remember how to do this. We're going to put the 6x in y equals, and then we're only going to graph a portion of it. Okay, let's figure out what portion we're going to graph. This first alligator looks like my hand before I open it up to make a L. So it's left or less than. This other alligator is not my left hand when I open it up. So it's going to be right, the portion on the right, or greater than 1. Okay, let's put this 6x in y equals. But, oh, let me zoom in. But we're only looking for what's to the left of 1. Okay, so we're definitely going to have this whole curve come down to 0, but then we're going to have to include a little bit more. Let me zoom in. Maybe it'll make it look better. Yeah, okay. Okay, so we're going to draw all of this left side of the curve, and then that's to the x value of 0. We want to draw all the way to the x value of 1. So we're going to draw pretty much all of the curve, but stop right here at 1. Okay, let me zoom out and show you again what I mean. So here's 1 right here. So that means I'm going to draw the part of the curve all the way from the left to that x value of 1. Okay. So let's draw. So we're going to have something like that. Okay. And on the left, we're going to have an open hole at x is 1. So here's x is 1. It's the left side of the curve, and I'm going to have an open hole. What the heck happened? Oh my gosh, I put 6xx. What a moron. Okay, I'm not making this video again. Let me just delete this. Okay. Oh gosh. Boo honky. Yeah, I messed this way up. Okay. I'm not making this whole video again. Okay. Let's see here. So, my bad. I put too many x's in my y equals and it screwed up my picture. And so now we're just going to use the portion to 1 all the way up until 1. We're not going to use anything after that because that has the x value of 2, 3, 4, 5. So we don't want to use anything to the right. Okay, so here's 1, and our line comes, y'all were probably freaking out. Okay, up like this, and then at the end of that line, at that 1, so at that x is 1, we're going to have an open hole for the left part of the graph. So here's the left part of the graph. He has an open hole. All right, let's go back to y equals and type in that second equation. That second equation is just 6. All right. And press graph. Oh, look, it's just a straight side-to-side line. But I only want to draw the part when x is bigger than or equal to 1. Or the right side. So I'm only going to draw this part, not the left side. Okay? So I'm going to have a straight side to side. And for that right side, it says closed. So this right side, as we get to x is 1, it gets closed in. What? So it was open for the first part. But then when we went to graph the second part, we filled in that pothole. Oh no. Okay. So at first we had to open, but then the closed filled it in. Okay. So this is not A, not this one, not this one. Oh, it's B. Okay. Great. All right, it says the function is differentiable at x equals what? And that's going to be where that open hole got closed. So, where did our open dot get closed? It was at x equals 1. Hey-o! Okay, good. And don't forget, we are going to omit number 13 because it was too long. And I didn't want y'all to get it wrong. Alright, so let's go over this. You have to complete the online review with a 70 or more to gain access to the test. This is not the online review. The online review is an actual assignment underneath your homeworks. You have to complete it with a 70 or more before you take your test. If you have not scheduled an appointment, schedule an appointment. Okay. If you forget to schedule an appointment and we get iced in, well, you get a 0 because you didn't follow directions and make an appointment first. Okay. So if you don't make an appointment and the school gets closed, you lose that testing day because you never proved your intent to take your test. Whereas if you make an appointment and you get a flat tire, or you make an appointment and your wife goes into labor, or you make an appointment and you get in a car wreck or something. As long as you make an appointment, that shows your proof of intent, and I'll let you make up your test. However, if you forget to make an appointment and then you forget to take your test, there's no proof of intent and you will not get to make up your test. Okay, so make sure you do your review, your online review with a 70 or more. Don't forget to make a cheat sheet. Your cheat sheet can be one full-sized paper, and if I were you, I would just write the review. Number 1, it says factor. Then I would write the problem. And then I would not just write the answer. I would show the work to get to the answer. Okay? So for your cheat sheet, I would write down every single problem, especially the ones with work, like this number 4 that has a lot of work. You probably need to write it down so you have something to look at. Okay, email me if you have questions.